This is General Physics, Conservation of Momentum Assignment, page 219, problem number 32. This particular problem here, we have to take into account the vector nature of momentum. So we have this bale of hay being dropped in an altitude. We're given the weight of the hay bale. We can get the mass from that later by dividing by 9.81. But what is the momentum, magnitude, and direction does this bale strike the ground? The key to this problem is going to be much more kinematics than it is going to be momentum. All right, let's put together what we have here. This is the information we're given, and the key is going to be this guy down here, this V final. We're going to need to know him. So how are we going to get that? Well, what it is it ends up being a half parabola problem, because we know that the final momentum is just simply the mass, which is easy to get, times the final velocity, which is not so easy to get. We're going to get this final velocity through our projectile motion kinematics. All right, so let's look at impact. What we have here, we've got this two-dimensional V final. V final in the x direction is the same thing as V initial in the x direction. That doesn't change. And then there's V final in the y. And then we need to add those two vectors together to get our V final, which is really what we're after. Okay, the problem is getting this V final in the y. How are we going to do that? Because once we do have that portion, we can just use Pythagorean and get our V final. Okay, V final in the y, that is the sticker. Okay, well, we go back to our kinematics equations for projectile motion, and we analyze this just in the y direction, and we notice that the initial in the y is 0 gt. All right? Well, that's well and good, but what about time? Remember our strategies for doing projectile motion problems was finding time. And in our half parabola problems, this was our go-to for finding time. We looked at our distance in our y, in this case 60 meters. We make it negative because everything is done relative to the initial position of the bale of hay, which is up here at the plane, and it drops down a negative 60 meters. Okay, anyways, we can back solve this for time. Once we have that time, we can get our V final. We got our V final in the y, V final in the x. Pythagorean gets our V final. Now, what about this direction of my momentum? My direction of my momentum is going to be the same thing as the direction of my final velocity. Since I have those components, I can put those together, use the arctan in this case, and then I'm good to go. The very last part that I have to do is I have to find my mass by simply dividing. All right, these are all the pieces to the puzzle. A little bit tedious, put them together, and you're good to go.